Okay, so here is an equation. What you've been doing lately is you've been graphing things, and you're seeing where, like, we have a line like this, and we shade underneath it. And let's say we have a line going like this, and we shade underneath that. And then your common sense tells you that, like, let's say this is the number of bananas sold, and this is the number of the apples sold, that you can't sell negative apples, at least in this universe. And so you have to put a 0 figure, and here's another line that's going like this, no negative bananas. And so when we're all done, we get this region like this. It's called the feasible region. And then we usually have a profit function, which would be something like this. I'm talking about Super America. They sell apples and they sell bananas. And they sell bananas 3 for $1, which makes them 33 cents each to you and me. So do you agree that out of 33 cents, there's no way that's all profit? Otherwise, they get their bananas for $0. Okay, so then they're making less than 33 cents a profit on a banana. You have any clue what kind of profit margin they might be making on those bananas? You think 20 out of the 30 is profit? Okay. I think typically on grocery items, they have a much smaller percent markup than on others. Because you also have to factor in some bananas they buy, and they end up having to throw away because they aren't used or whatever. I'm going to go with about a dime on each banana, and you probably don't even make that much. But it's a nice thing. 10 cents for each banana, which is like Y, plus, well, they charge 75 cents for each apple. I'm thinking that they have a higher markup on their apples, though. Like they probably make more money on their apples. If they're 75 cents each, they can afford to maybe make 10 cents is like maybe a little bit small. Maybe they make 20 cents on each apple. Oh, and the apples are not A, they're X, because they're on the X-axis. You'd have P is equal to all of this. That is your objective, or your profit function, or your cost function. It depends on the problem. And then which are the points that could possibly be the answer? It's a lot of this graph. That one, that one, that one, and is 0, 0 evenly, though, where you're going to make the most profit? No, that doesn't make any sense. So yeah, it's a corner of the feasible region, but you don't need to even use that one. So it's one of these 3 spots where they'll make the most profit. Okay, I'll give you numbers, and I want you to check and figure out which one is the most profit. Let's say this point right here is on a typical day at their store. So let's say that this is about selling 25 bananas. 0, 25. That spot right there is 18, 20. And lastly, this spot right here is at 0, 30. No, 30, 0. Figure out how much profit they're going to make on their fruit sales. And which of the corners they would probably want, therefore. I'll pause for a second. Which one was the best? 0, 25, 18, 20, or 30, 0? You might assume 1820 would be the best, but profit on apples is higher. 20 cents, twice as much profit on apples, so having a lot of apples might be really good. And that 30 times the 20 comes out to $6, as opposed to the 18, 20, which would be $1.80 and $4, adds up to a total of $5.80. Yeah. It's actually better to sell all apples. So, given that, do you see why some executive at FA might say, let's just quit selling bananas. Make a lot more money selling apples. Does that mean that they should for sure do that? Yes. What do you think? This only is looking at the fruit sales. Very good. So if you got, if there are bananas out there, how about this? If I was going to offer you one right now, how many would choose banana over an apple? 2, 3, 4, 5. How many of you choose the apple? Well, that's most of you. Most of you like the apples, but there's a fair number of people who just really would rather have a banana. And then if they don't have those at SA, they're going to probably go somewhere else. And they're going to do all the shopping there, like their gas and their, ATM use and all that stuff. It's going to happen at the others. So you can see why they for both, even though. But if they're going to like try to advertise and get people to buy more, do you get how they might want to advertise more towards the apples? Because there's more apple lovers and they make more money on the apples too. So this is how you could actually use it in a real business situation. All right, now let's talk about, I made this point right here, 18, 20. Now if you actually graph both lines really carefully on a piece of paper, you can see where they cross. But there is a way to do it on your calculator that I want you to get good at. Here's an equation. Let's say I was going to try to get the answer for that equation. Well, there isn't an answer. There's a lot of answers. There's a lot of combinations of 3 and 2 that would make up 200. All right, that's a graph. You'd graph that line. How do I get this down to be just a line you could put in your calculator? You solve both sides for y. Solve the left side for y. Get the y alone. So you subtract 3x from both sides. That cancels that. And now we have to divide by 2. And I end up with y equals negative 3x divided by 2 plus 200 divided by 2. And 200 divided by 2 is really 100, right? So let's say this other line that was at, let's say, how do I know where these two lines cross? Let's say that I know it kind of looks like this. One line, the other line. And I know they're going to cross somewhere. How do I know where they cross? You graph both of them and see where they cross. All right, so what'd you write now? On your y equals screen, graph the two equations. Negative halves x. If you want to call that negative 1.5x, that'll make it easy. No, don't put the 100 in first. Put in the negative 3 over 2x. Now, this, put it in a parenthesis. You have a half right here. All right, I'm going to pause for a second while I get that up on my calculator. Okay, so I got these two lines in my calculator. Graph. As long as my window is big enough, I'll be able to see where they cross. And my window is big enough. I can see where those two lines cross. If yours isn't, you'd have to increase your windows. How do I do that? I go to my window, and I got mine going from negative 10 to 50 on both the x and the y. Yeah. Basically, if you make your x maxes go up to at least 50, then I'll be able to see these fairly big numbers. Everybody gets so you can see the graph on your calculator. If you can't see where they intersect, you can't do this next really cool thing that I need to teach you, which is finding out where are those two lines crossing. Well, there's an app for that, so to speak. There's a little button for that. You go second, calculate, it's right above trace. And which do you think we want? Intersect. And if you keep it to only two lines that you graph, if you only graph two lines, it's really simple. You go second, calculate, intersect, and you go enter, enter, enter. Because the first question they ask you is, am I on the first line? Yes. And then they'll go to the other line and they'll say, am I on the second line? Yes. And the third thing they ask is guess, which means you're supposed to like move the little spider over until it's like right where they cross. But if you only have two lines that are straight, there's only one place where they cross. So you can just hit enter automatically. Enter, 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 and the spider jumped to right where the two lines cross. And it says the intersection's at 40, 40. All right, I'm going to give you two new equations, and we're going to see where they cross. Go back to your y equals screen. Let's keep it simpler. Let's say negative 4x plus 10. And let's make the other one Oops. You can't know this. Board is not reacting well. I do stuff that sometimes does it twice or something. So hit it twice and only does it once. Anyway, well, let's make this a negative 2x plus 4. There. Make graph on that one. Okay. Now where are those crossing? Well, I'm going to zoom box it. I'm going to hit the zoom and go zoom box, and I'm going to box in the area that I want to see. And you get to where you're close, and then I'm going to hit enter to start the corner of the box, and then I'm going to arrow over and just box in the place where they cross. This zoom box is really handy to get the area that you want to see better. If you can get it so you can see the two lines crossing, now for the process, intersect. Try it. Like to see it on your screen. I'm going to walk around the room and make sure you got to the right spot. Now, while I'm doing that, I'm going to talk to you about how, do you get how this would not be a good real world answer? Why would this not be a good real world answer? Yes, you can't have negative, like say it's apples and bananas. The store cannot sell negative bananas or negative apples. It's not logical, it's not okay. Just a second. It's just the equation. That's weird. Okay, hit the graph again. Second, calculate, intersect, enter, enter, enter. That's the answer. I don't know what you did before, but that's the right answer. Yes, you may use the report up there. Or if you want a wall charger, you can have it on the. Give me something for collateral. Excellent. Good job. Okay. Okay. That is a smidge. Go back to your. I don't think you did second calculate intersect to find it. I think you tried to use trace. Now you go enter, enter, enter. That's it. Get that? Yes, sir. Check. Good. All right. It looked to me like you. Okay. Ask the kid sitting next to you. Okay. I haven't got them all, but I think almost everybody got this. Second, calculate intersect, which is number 5. And then what do I do now? Enter, enter, enter. The first question is, what line am I on? Am I on the right line now? Am I at the right spot? And it tells you 3, negative 2. Negative apples is possible. So there is a how to find where two lines cross. Why do you need that? Because you're going to have a picture that'll look like this. And we're not just going to tell you what this spot, where this spot, where this spot is. And now these spots are usually pretty easy to tell because they're the x-intercept where y equals 0, or the y-intercept where x equals 0. But this spot where the two lines cross, that one you'll need something for. So, all right, are there other ways to solve it? Yes, you could solve them algebraically too. If you wanted to solve y equals negative plus 100 and y equals negative plus 5, do you remember how to solve this with systems of equations? Like you can add them together and do elimination, or you can do what's called substitution. All right, those are skills that are valuable. Right now I'm focusing on how to do it with the calculator, so we may talk more about that. All right, now I asked you to get your homework up, and it looks something like this, except not nearly so messy. Clear ink. All right, and I really don't like the very first problem, the one about the, so we're not doing that one. What, did you start on that early? Shouldn't have. Should have been staying with me. All right, nope, it's not assigned. We're going to problem, I guess technically 3, I don't know why, but magician payment. All right, we're going to do this one together. You have 2 homework problems for tonight. These are big problems, which is why there's only 2. Magician's payment, we're going to start. All right, I want you to read it over thoroughly. And for those of you that can't read, I will read for you. School is contracted with a professional magician to perform at the school. The school is guaranteed an attendance of at least, and total receipts at least 4,800. Now, what they mean by total receipts is all the money total, like not how much they pay the magician, because he gets the total receipts is all the grand total, how much money they make. The tickets are $4 for students and $6 for students, which usually means parents. You know, what's a student other than that, I guess, a little baby. Of which the magician receives $2.50 and $4.50 respectively. What's the minimum amount of money received? Okay. Remember, these things look like this. And you have 2 lines, but this time, when you have your 2 lines, they're not limited. I want to think about that for a second. Stop, shut your iPads. Okay. Why are they not limited? They're lines when you shade them. Think about this. There's no light on it. Why? What about the problem we just read? Tell me that there would be no limit on it. Yes. Yeah, it's at least 1,000 people are going to show up. They didn't say the most we can have is 2,000. They said at least 1,000. So that means it could be 5,000. It could be 25,000. At some point, if this is the real world, you have to have a limit on how many people you can hold in your stadium or whatever, but they didn't tell us any limits. So when we do this problem, like feasible, everything above these lines that's above both lines. So basically it ends up being wherever it's shaded double above this, so that spot and that spot will be pretty easy because 0 student tickets or 0 adult tickets. And then it's this shaded region like this. Answers have a limit. They just keep going forever. Okay, my feasible region vertices then are this spot or that spot. Those are the 3 spots you will be checking. So let's get the equations for this, and your graph will eventually look something like that, except neater. For the graphing, I recommend that you add a page and it adds the bottom of your document. It becomes like your 3rd page of your document. Then you can rearrange the order of your document if you want to, but and as far as the graph goes, you do not have to do this on graph paper because we're going to be using the calculator to tell us where the intersection points are and stuff. All right, so you just need a big old graph, though, like this. And now what are we going to graph? Well, we got to get some equations first. So on this page that says magician's payment, let's get our equations written. We got some x and we got some y, and when you add the y, x and the y together, yeah, you're not going to be able to add a piece of graph paper. I just said you don't want to use graph paper, you want to use regular paper. Just sketch it like this, and when your lines are done, it'll look like this, and we'll later where these cross. Okay? Okay, so back to, sorry, I just somehow lost the magician's payment thing. Where'd it go? Okay, here it is. All right, so give me an equation. Somebody smart has looked at this problem and knows what happens when I add x and y, or when I add 6x and 4y, or that kind of stuff. What do you think, guy in the blue shirt, who shall remain unnamed? 4x plus 6y. Very good. That just figured out the, which is the students, and the money for the not students, and what do we know about them? That's a, but encourage you to finish right now. You've got it. Excellent. You're going to rearrange it for me too, so there's equals. Okay. You have 4, 6. Let me make sure you're right out. Very good. And then it's plus, and then it's 4,800 divided by what? It just comes. Well, it was 48 divided by what though? All right. Let me make sure you do that right too. Yeah, that's right. Excellent. Okay. So now, 4 6 is the one thing if I had a bone to pick with you, I suppose we could change 4 6 to 2/3. Okay, other than that, that was awesome. So now I graph that, and now that's going to generally look like something like that. It's negative, so it's got a slope down like this, right? All right. Now what's the other one? What's the other part? Yes, sir. This is because the number of students, X's and the Y's, and the not students together have to be greater than or equal to, what did you say? You are correct. And this one's a little simple to put into Y equals form. We just put the X over to the other side and make it negative X plus 1,000. All right. So there we have it. We've got another line. And see where the two lines cross. If I were you, I'd put them in the graphing calculator. First, you got to be able to find it. You might have to set your window big enough to see 4,800 and see where they cross. Yes, ma'am. Okay. All right. Well, I've both as greater than or equal, but what you're making me question is whether or not there's a chance I was supposed to flip the sign around to be the other way around. And I never multiplied or divided, did I? I don't think I did. So bottom line is I think that they are correct the way I have them on the board. Yes, sir. Listening. Okay. Both of you two. Yes, you are correct. I'm running a little bit late right now, so what's up? All right. So we've graphed. Hopefully, you've graphed on your calculator these two equations and see where they cross. Generally speaking, it should look something like this, and you'll find the spot where they cross. Above that line like that. So now my answer is either here, or here, or here. And I take points and I put them into what? I haven't written that equation yet. What is that equation supposed to be? The profit equation. 250, the 450. And how do I do that? I go 250 for each X plus 450 for each Y equals, I don't know, his profit. Don't try to graph that one. That's the one where you from the graph and you stick to that equation. Sorry, my this thing keeps going in and out my microphone, but I can't seem to fix it. I have a new one being ordered, so. Okay. These points, this point, and this point, and put them into this equation and figure out which is the one they're asking. The magician is asking, what's the least amount of money that I could get out of this deal? So we want actually the lowest amount this time, not the highest amount. Because frankly, we don't know the highest amount. Because if 100,000 people show up, he could make this insane amount of money. He wants to know, like, what's the minimum amount of money I get from this? So he wants the smallest amount. All right, any questions? I know you might be afraid to have big groups, but if you have a question individually once we stop, then it'd be great. That's all I got for the video for today.